Today's notes are on rational zeros. Again, we want to remember that the zeros of a function are any x value that makes f of x equal to 0, also referred to as the solutions, roots, and x-intercepts. A rational number is a real number that can be written as the ratio of two integers. Rational numbers in decimal form are terminating or repeating. What are the rational zeros of a function? The rational zero theorem says if f of x is equal to ax to the n power plus bx to the power of n minus 1 plus cx to the power of n minus 2 and so on until you have plus the constant has integer coefficients, then every rational zero of f of x has the form p over q, where p is the factors of the constant term c and q are the factors of the leading coefficient a. For example 1, it wants you to list the possible rational zeros of 3x cubed minus 4x squared minus 17x plus 6. So I want you to do p over q, where p was the factors of the constant 6 and q was the factors of your a value, which was 3. So factors of 6 would be 1, 2, 3, and 6. Factors of 3 would just be 1 and 3. So then you're going to think about rewriting this out. So 1 over 1 is 1. 2 over 1 is 2. 3 over 1 and 6 over 1. Then we're going to go back and we're going to put everything over 3. So you get 1 over 3, 2 over 3. We don't have to list 3 over 3 because that simplifies to 1. And we don't have to list 6 over 3 because that simplifies to 2. Because all of these could be a factor with a positive or a negative, you need a plus or minus in front of all of them. So let's look at example 2, listing all the possible rational zeros. So my p over q, so p being our factors of 8, over the factors of 2. So factors of 8 would be 1, 2, 4, and 8. Factors of 2 are just 1 and 2. And we can't forget the plus or minus out front. So if I first go through and put everything over 1, I get plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. Then if I put everything over 2, I get plus or minus 1/2, plus or minus 2 over 2, plus or minus 4 over 2, and plus or minus 8 over 2. 2 over 2 simplifies to 1. 4 over 2 simplifies to 2, and 8 over 2 simplifies to 4. Because all of those are already listed, we don't need to list them again, which means that these 5 make up our possible zeros. Please try and do the same thing with example 3. The next part of the notes talk about checking to see if a given x value is a 0. So it wants us to check if 1, -1, and -2 are zeros of the function. In order to do this, test the possible rational zeros by using synthetic division. If the remainder is 0, then the value is a 0 or a solution of the function. If it is not a remainder of 0, then it is not a 0 of the function. So for example 5, it wants us to go through and check and see if -1/2, 1, and 2 are zeros of the function. So we're going to use synthetic division for all of them. So starting with -1/2, I have 2, 1, 0 for my x cubed term, which is missing. And we need a 0 for the x squared term. Negative 32 and negative 16. We're going to bring down the 2. Negative 1/2 times 2 gives us negative 1, which we're going to add together, which will give us 0. And we're going to keep following along that pattern. Alright, because we finished our synthetic division and our remainder was 0, we can say that yes, negative 1/2 is a rational 0. And we want to check this for the other two numbers as well. So first, looking at 1, I'm going to use the same coefficients as before. And this gives us a remainder of negative 45, which means x equals 1 is not a rational 0. And our last one here, going through and completing our synthetic division. We get a remainder of 0, which means that x equals 2 is a rational 0. Please turn to the next page of your notes. The next part talks about when to use the rational 0 theorem. You're going to use it if you are asked to find the rational zeros of a polynomial and they do not give you a 0 or a factor to start with. So example 6, it works through here for you. Find the rational zeros of the function. So it starts by listing all of the possible zeros. You are then going to test one of the possible zeros to see it as a solution using synthetic division. You are going to keep testing and keep guessing until you find one that gives you a 0, such as x equals negative 2. Then you're going to write your answer as a polynomial, so 3x squared minus 10x plus 3, and you are going to factor that. After you get your factored form of the polynomial, you're going to set each factor equal to 0 and solve to find the remaining rational zeros. So don't forget the x plus 2 or the x equals negative 2 from your testing up in step 2. And then our two new factors, x minus 3 and 3x minus 1, to get your last two zeros. Remember that if the highest degree of the original problem was 3, then you should have 3 zeros. Let's go ahead and look at completing an example on your own on the next page. We're going to start by listing out all of the possible zeros, so that's our p over q value. So p is the factors of 4, so I get 1 and 4, and then 2 times 2, so 1, 2, and 4. Factors of 3 would be 1 and 3. If I list these out, I get 1 plus or minus 2 plus or minus 4 plus or minus 1/3 plus or minus 2/3 and plus or minus 4/3. Then we're going to test one of the possible zeros to see if it is a solution using synthetic division. If it is not, we'll test another one until we find one that is a zero. So first I'm going to try testing +1. So I have the coefficients 3, 1, -8, -2, and 4. And we're going to go through our process of synthetic division. Right, so the first one does not give us a remainder of 0, so it doesn't work. So I'm going to guess another number. Remember that you can try the positive or the negative version. So next I'm going to try -1. So going through my synthetic division, I'll bring down the 3, multiply, add, until I get to the end. This time I do get a remainder of 0, which means I can move on to step 3. We're going to take the values from the synthetic division and write them as a polynomial and factor it to find the other factors. So we're going to get 3x cubed minus 2x squared minus 6x plus 4. Because this is already a 4-term polynomial, we can go straight to grouping. So the first set has a greatest common factor of x squared, leaving me with 3x minus 2. I can pull a -2 out of the next one to get 3x minus 2. So this factors to 3x minus 2 and x squared minus 2, which completes step 3. Step 4 is going to have us set each factor equal to 0, including our original one, which gave us a -1. So we can't forget x equals -1. Then I have 3x minus 2 equal to 0, and x squared minus 2 equal to 0, and we're going to solve them both for x. So the first one gives us 2/3. So 2/3 would have been another one that would have worked for us in step 2. And then the last one, we get x squared is equal to 2. So you'll have to take the square root of both sides to find that x is equal to plus or minus the square root of 2. Please follow these 4 steps and try and do example 3 on your own.